Module 10, the Income Expenditure Model. The Keynesian view of macroeconomics was developed during the Great Depression in the 1930s, long before the ADAS model was popularized. Keynesian economics was traditionally explained with a different approach known as the income expenditure or Keynesian cross model. The Keynesian cross model is still useful today because it provides a much more detailed and intuitive explanation of aggregate demand than is given in the ADAS model. Aggregate expenditure function, a graphical representation between national income as a function of aggregate expenditure, which is defined as consumption plus investment plus government spending plus net exports. There's an aggregate expenditure schedule that has the aggregate expenditure function expressed as a table. The fundamental assumption of Keynesian economics is that economic activity, that is, output and employment, are determined primarily by the amount of aggregate demand or total spending, hence expenditure, in the economy. The model makes no explicit mention of aggregate supply or the price level. Remember that GDP can be thought of in several equivalent ways, measures both the value of spending on final goods and services and the value of production of final goods and services. So we can build an aggregate expenditure schedule that shows AE, aggregate expenditure, equals C plus I plus G plus net exports, which is exports minus imports. And we can graph it here, GDP on the horizontal axis, AE on the vertical. A key part of the income expenditure model is understanding that as national income or GDP rises, so does aggregate expenditure. Here's some vocabulary. Autonomous consumption, the amount consumers spend if their income was zero, i.e. consumer spending which is caused by something other than income, for example, borrowing. Consumption function, a graphical relationship between national income and consumption expenditure. Algebraically, consumption equals A plus MPC times Y, where A is autonomous consumption, the amount of consumption expenditure when Y is zero. MPC is the marginal propensity to consume, which is the slope of the consumption function, and Y is national income. MPC, the fraction of any change in income which is spent. Algebraically, MPC equals change in consumption over change in income. Marginal propensity to save, fraction of any change in income which is saved. Algebraically, MPS equals change in S over change in Y. The aggregate expenditure consumption as a function of national income. In the expenditure output model, how does consumption increase with the level of national income? Output on the horizontal axis is conceptually the same as national income, since the value of all final output that is produced and sold must be income to someone somewhere in the economy. At a national income level of zero, $600 is consumed. We can read that off the AE vertical axis. Then each time income rises by 1,000, consumption rises by 800, because in this example, the slope of the line, the marginal propensity to consume, is 0.8. Here's some more information. Aggregate expenditure function, a graphical relationship between national income as a function of aggregate expenditure, which is defined as consumption plus investment plus government spending plus net exports. Aggregate expenditure schedule, aggregate expenditure function expressed as a table. Autonomous expenditures, all the components of aggregate expenditure, which do not vary with national income. These include autonomous consumption, investment, government, and export expenditures. Government spending function, that's the horizontal line showing the relationship between national income and government spending. Investment expenditure function, horizontal line showing the relationship between national income and government spending. Marginal propensity to import, fraction of any change in income which is spent. Algebraically, MPI is the change in imports over change in income. Net export function, a graphical representation or a relationship between national income and net exports, exports minus imports. So here we have income as a function of national income, investment as a function of national income. The investment function is drawn as a horizontal line because investment is based on interest rates and expectations about the future, and it does not change with the level of current national income. In this example, investment expenditures are at a level of 500. However, changes in factors like technological opportunities, expectations about near-term economic growth, and interest rates would all cause the investment function to shift up or down. Government spending and taxes as a function of national income. The level of government spending is determined by political factors, not by the level of real GDP in a given year. Thus, government spending is drawn as a horizontal line. In this example, government spending is at a level of 1,300. Congressional decisions to increase government spending will cause this horizontal line to shift up, while decisions to reduce spending would cause it to shift down. Exports and imports as a function of national income. The export function is drawn as a horizontal line because exports are determined by the buying power of other countries and thus do not change with the size of domestic economies. In this example, exports are set at 840. However, exports can shift up or down depending on buying patterns in other countries. B, the import function is drawn in negative territory because expenditures on imported products are a subtraction from expenditures in the domestic economy. In this example, the marginal propensity to import is 0.1, so imports are calculated by multiplying the level of income by negative 0.1. Putting it all together, we can have the aggregate expenditure function. The lowest line is just C. You can add in C plus I plus G, C plus I plus G plus net exports, and then you get the the expenditure function, the aggregate expenditure function, which is the highest. And continuing along, we can see graphing it again in different colors and then having the next net exports line on there, what it looks like. Equilibrium in the expenditure income model. Consumption function, graphical representation between national income and consumption expenditure. Algebraically, C equals A plus MPC times Y, where A is autonomous consumption, the amount of consumption expenditure when Y is 0, MPC is the marginal propensity to consume, and Y is national income. Income equals expenditure line. All combinations of national income and aggregate expenditure, where national income equals aggregate expenditure. Graphically, this is the 45-degree line on the Keynesian cross diagram, or income expenditure model. So here we have it. The 45-degree line shows every point where the amount of income, real GDP, equals spending in the economy. So the macro equilibrium occurs at the level of GDP where the aggregate expenditure line crosses the 45-degree line. The equilibrium is at point E. It's the only point on the aggregate expenditure line where the total quantity of goods and services being purchased, AD, equals the total quantity of goods and services being produced, AS. The meaning of equilibrium remains the same. That is, equilibrium is a point of balance where no incentive exists to shift away from that outcome. Finding equilibrium using algebra. In this model, the equilibrium occurs at the level of GDP where aggregate expenditures equals national income or GDP. Given algebraic equations for the aggregate expenditure line and the income expenditure line, the point where they cross can be readily calculated. Step 1, determine the aggregate expenditure function. Step 2, the equation for the 45-degree line is the set of points where GDP, or national income on the horizontal axis, is equal to aggregate expenditure on the vertical axis. Thus, the equation for the 45-degree line is AE equals Y. Step 3, the next step is to solve these two equations for Y, or AE, since they will be equal to each other. Substitute Y for AE. Step 4, insert the term 0.3y for the average tax rate, T. This produces an equation with only one variable, y. Work through the algebra and solve. So imagine an economy defined by the following. C equals 140 plus 0.9yd. This is the consumption function, where 140 is autonomous consumption, 0.9 is the marginal propensity to consume, and yd is disposable income, i.e. after tax income. So yd equals y minus t, where y is national income or GDP. T equals tax revenues, or 0.3y. That's given. Note that 0.3 is the average income tax rate. I, investment is 400. G, government spending is 800. Exports are 600. Imports are 0.15y. Step 1, determine the aggregate expenditure function using the numbers from above. It is, putting it all together, 140 plus 0.9y minus t plus 400 plus 800 plus 600 minus 0.15y. Keep going. Step 2. The equation for the 45-degree line is the set of points where GDP, or national income, on the horizontal axis is equal to aggregate expenditure on the vertical axis. Thus, the equation for the 45-degree line is AE equals Y. The next step is to solve these two equations for Y, or AE, since they will be equal to each other. Substitute Y for AE. Y equals AE equals all those numbers from before. Insert the term 0.3y for the tax rate t. This produces an equation with only one variable, y. Work through the algebra and solve for y, and you should get y of 3,730. That's the equilibrium. Recessionary and inflationary gaps in this model. Inflationary gap, when the macro equilibrium occurs at a level of GDP greater than the potential GDP. Thus, unemployment is lower than the natural rate. Potential GDP line, the vertical line on the Keynesian cross diagram indicating where GDP on the horizontal axis is at potential. Recessionary GDP gap, when the macro equilibrium occurs at a level of GDP less than the potential GDP. Thus, unemployment is higher than the natural rate. Now let's look at it with the vertical potential GDP line. A vertical line shows potential real GDP. GDP increases from left to right on the graph. So here we can see in panel A that must be a recessionary gap because the equilibrium, the cross, is lower than potential. Here in B we can see that it must be an inflationary gap because the potential GDP is lower to the left of where we actually are, where the equilibrium is, where the cross is. Recessionary and inflationary GDP gaps. If the Keynesian cross diagram in the Keynesian cross diagram, if the aggregate expenditure line intersects the 45-degree line at the level of potential GDP, then the economy is in sound shape. The equilibrium might be higher or lower. What might cause a recessionary gap? Anything that shifts the aggregate expenditure line down is a potential cause for recession, including a decline in consumption, a rise in savings, a fall in investment, a drop in government spending, or a rise in taxes, or a fall in exports or a rise in imports. The spending multiplier in the income expenditure model. The spending multiplier is 1 over MPS. You could also think of it as 1 over 1 minus MPC, because MPS equals 1 minus MPC. The power of the multiplier effect is that an increase in expenditure has a larger increase on the equilibrium output. The increase in expenditure is the vertical increase from AE0 to AE1. Here we can see it as it shifts up. However, the increase in equilibrium output shown on the horizontal axis, going from 800 to 700, is clearly larger. Thus, the spending multiplier, change in Y over change in AE, is greater than 1. The spending multiplier and changes in government spending. Recall that the macro equilibrium in the income expenditure model is found at the point where the level of GDP or national income equals aggregate expenditure. The formula for aggregate expenditure is C plus I plus G plus net exports, which is exports minus imports. And then there is the review slide. So there's 2 slides with a quick review, questions you should go over. Again, this is getting long. I will let you read those over. They're also in the files where these PowerPoint slides live. So that's all.